Okay, here is your vocabulary for the next unit, and the next unit is going to be Chapter 5, and we're going to work on the Pythagorean theorem, and we're going to work on radicals or square roots. And you may have seen the square root sign before. It looks like this. And you already know what this means. So this and this are just opposite each other. So we're going to talk about that. So here are the vocabulary words that you need to know, and you will have a quiz on them. So you want to study these vocabulary words. All right, let's go here. A square root basically is telling you that whatever number is inside here, so let's say 25, has a number that's multiplied by itself to equal that. So we know that 5 times 5 equals 25, or 5 squared equals 25. So this just tells me that this part right here tells me that there is a number that can be squared, that means multiplied by itself, to get what's inside that. So that is what it looks like, okay? Radical symbol, you need to know that. A non-negative square root is represented by that. That means that that is a positive number. So if that were 25, then that would equal a positive 5, right? So positive 5 squared, okay? Or the square root of 25 equals 5. We know that, okay? A negative square root is represented by a negative sign and a square root symbol. And you always know that if you don't see anything next to it for a coefficient, there is an invisible 1. Remember, the 1 always wears the invisibility cloak. So really what this negative means is that whatever is on the inside of that square root symbol is being multiplied by a negative 1. So if you know that the square root of 25 equals 5, and you have a negative symbol, that means that negative 1 is being multiplied by that 5 to give you negative 5. Okay? Again, we can do another example. If you had the negative square root of 100, you know that 10 times 10 equals 100. So the square root of 100 equals 10. And then you've got that negative symbol there, so that means a negative 1 times 10 equals negative 10. So the negative square root of 100 equals negative 10. And we'll go over this more in class. We'll do lots more examples. Perfect squares mean that numbers can be multiplied together to give you square roots, and that there are no decimals involved. So you know that the square root of 0. Okay, so the square root of 0 means what times what equals 0? Well, we know that 0 times 0 equals 0, so the square root of 0 equals 0. The square root of 1, what times itself equals 1? Well, we know that 1 times 1 equals 1, so the square root of 1 is 1. The square root of 4, these are all perfect squares. That means that there are no decimals involved. No decimals involved. And I know you all like that. Okay, so the square root of 4, well, what times itself equals 4? We know that 2 times 2 equals 4, so the square root of 4 equals 2. The square root of 9 we have here. What times itself equals 9? 3 times 3 equals 9, so the square root of 9 is 3. Square root of 16, what times itself equals 16? Well, 4 times 4 equals 16, so the square root of 16 is going to equal 4. Now we have the square root of 25. What times itself equals 25? 5 times 5 equals 25. So the square root of 25 is 5. Square root of 36. What times itself equals 36? Well, 6 times 6 equals 36. So the square root of 36 equals 6. Square root of 49. What times itself equals 49? See a pattern forming here? 7 times 7 equals 49. So the square root of 49 is 7. Square root of 64. What times itself equals 64? 8 times 8. 8 times 8 equals 64, so the square root of 64 is 8. Here we have 81. The square root of 81, that means 9 times 9, because 9 times 9 equals 81. So the square root of 81 is 9. The square root of 100, that is 10 times 10. So the square root of 100 equals 10. Remember, you are looking for a number, multiplied by itself giving you a perfect square. You know that if I were to say 4 squared, it's the same as saying 4 times 4, or 16, the square root of 16. Okay? So all of these are equal to each other. The square root of 16 is 4. We know that because we know that 16 is 4 times 4. So it's that number 4 that's multiplied by itself to give me that. So, oh, check that out. So 16 here, the answer is 4. Okay? Well, remember we have that 1 here, so I don't worry about that until after I figure out what is multiplied by itself to equal 9. Well, I know that 3 times 3 equals 9, so the square root of 9 equals 3. And then I had that negative 1 there that I need to multiply by, so the square root of the negative square root of 9 is equal to negative 3. Okay? So let's find the square root. Now, when we have fractions here, don't be scared, squared. We just do the top first. So what's the square root of 25? Looking for that perfect square. What times itself equals 25? And 5 is correct. And then I just keep my division sign there like a fraction, and I do the 81. What times itself equals 81? And that would be 9. So the square root of 25 81s is 5/9. And 4 is a perfect square also. What times itself equals 4? And the answer to that is 2. And don't forget you have a negative 1 here. So first we do what times itself equals 25, and the answer to that would be 5. And then don't forget you have your negative 1, so it's multiplied by negative 1, so you would have a negative 5 there. Okay, so real quick, let's go through the rest of these vocabulary words. Natural numbers are just your counting numbers. Those are the ones you count on your fingers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are all the ones that you learned before you started kindergarten. Whole numbers are all of your natural numbers, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus 0. So you just added 0 to the natural numbers. So you have 0, 1, 2, 3, 4, 5, 6, and so on and so forth. Integers just means that you have all of your whole numbers, so 0, 1, 2, 3, 4, 5, 6, all your counting numbers, whole numbers, plus you have the negative numbers, so negative 1, negative 2, negative 3, negative 4, negative 5, etc. So it means that you have all of those and all of those plus the negatives, plus negatives. Okay? Rational numbers means that you have basically anything that isn't anything that's not irrational, and we'll talk about irrational numbers. But your natural numbers are rational, your whole numbers are rational, your integers are rational, decimals, that end, the terminating decimals, which are these right here. That means that they have an end to them. So like you have the 1.5, 2.75, 3.25, 4.2, 4, 5, 6, 7. It ends right there. Any decimals that end are called terminating decimals. Okay, decimals that end. Also, repeating decimals, that means like you had 1.3333333. That means that that 3 is repeating. So repeating decimals are also rational. Repeating decimals are rational. And then you've got your irrational numbers, which, oh, sorry, up here, also your perfect squares. Perfect squares are also rational. So your, like we talked about earlier, your perfect squares, like the square root of 4 is 2. The square root of 25 is 5. All of your perfect squares are rational numbers. Now, down here, you have two things that are irrational numbers. Your not perfect squares, so 13, which is going to give you a decimal, that decimal is going to be 3 point something, and we would have to work that out to figure out what it is. But any square root that is not a perfect square, so not perfect squares are irrational. Also, your decimals that never end and don't repeat, like pi. The number that represents pi, I know you all know it is 3.14, but actually pi, 3.14, keeps going on forever and ever and ever, and as of today, they still have not found an end to pi. We just round it to 3.14. So you have your square roots that are not perfect squares, such as the square root of 13, which would be 3 point, it would be a decimal, and your decimals that never end, such as pi, that never ends. So tomorrow we're going to talk, I'm going to give you a whole bunch of examples. You're going to have to be able to tell me if they're rational or irrational. So you may want to go ahead and memorize that these are your things that are rational, and these are your things that are irrational. You need to memorize those two things. Memorize, people. You need to memorize the vocabulary. And it looks like that is it. So make sure you have taken notes. Yay, we like notes. And you will need to show those notes to me tomorrow in order to get credit for watching this instruction. And you will need to know the difference between irrational and rational numbers. So you need to memorize those lists. You will also need to know how to find perfect squares. Okay, that means that a number multiplied by itself. So the square root of 81, that's 9 times 9, so the square root of 81 equals 9. Okay, you're going to have to know those perfect squares from 1 through 100. So you might want to make sure you know those. If I were you, I'd go through them all. 1 times 1 equals 1. 2 times 2 equals 4. 3 times 3 equals 9. 4 times 4, sorry, that should be through 10, not 100. I lied, It's actually perfect squares through 100, but your numbers will be 1 through 10. Okay, so you should be able to tell me the square root of 1, the square root of 2, the square root of 3, the square root of 4, the square root of 5, the square root of 6, the square root of 7, the square root, sorry. That's not what I want you to do. You should be able to tell me the square root of 1, the square root of 2, the square root of 4, the square root of 9, the square root of 16, the square root of 25, the square root of 36, the square root of 49, the square root of 64, the square root of 81, and the square root of 100. Okay, you're going to have to be able to tell me those. That's 1. That's not a perfect square, so I don't know why I put that on there. That's 2. That's 3. That's 4. That's 5. That's 6. That's 7. That's 8. That's 9. And that's 10. So you need to know these. People, you need to memorize those, because if you don't memorize those, the work that we're going to do tomorrow is going to be a lot harder. So memorize these, memorize irrational versus rational, and you will be golden. Love you all. Have a great night.